Hello. In the videos before this one, you've learned how to set variables and how such variables can be used to perform mathematical operations. To proceed further with computer programming, you need to understand how we can use the values stored in the states of variables to determine what code is executed within a computer program using logic statements. To understand this procedure, we are going to consider how one might write a program to calculate the modulus of a number. This function, the modulus, is often written using the symbols shown here. Furthermore, a graph showing the modulus of the numbers on the y-axis against the input variable on the x-axis is shown here. What you should be able to see from this graph is that f of x is calculated by replacing the sign of the input variable x with a positive sign. In other words, f of x is calculated using the expression shown here, which reads as follows. If x is less than 0, i.e. if x is negative, then f of x is equal to minus 1 multiplied by x. If x is greater than or equal to 0, i.e. if x is not negative, then f of x is equal to x. Importantly, when we write x is less than 0 in an expression such as this one, we are writing a logical proposition. This is important as a proposition such as x is less than 0 has a truth value. The truth value for the proposition is 1 if the proposition is true and 0 if the proposition is false. In this case, the proposition x is less than 0 is equal to 1 if x is negative, and the proposition x is less than 0 is equal to 0 if x is not negative. We can express how the modulus is calculated diagrammatically by using a flowchart. The value of x enters this flowchart from the left. The truth value of the proposition x is less than 0 is then evaluated. If the proposition's truth value is 1, then y is evaluated as minus 1 times x. If the truth value of the proposition is 0, then y is set equal to x. Within Python programs, we can write code that exploits the truth values of propositions in the way that I've just described in these flowcharts by using if-else blocks. A Python code to complete the task illustrated in the flowchart at the top of the page is shown here. The decision as to how to compute y is made by this line that contains the if statement. As you can see, the logical proposition x is less than 0 that appears in the flowchart appears here. The code shown here is executed if the proposition is true. If the proposition is false, by contrast, the code shown here is executed. Let's finish by digging a little further into the anatomy of these if blocks. Consider the slightly more complicated code that is shown here. Once again, the code that is executed is decided by the truth value of the proposition. Now though, two variables are set rather than one, as Python will perform all of the instructions underneath the if statement that have the same indentation level when the proposition is true. Finally, notice that less than is not the only binary operation that can appear in our propositions. We can also use any of the following sets of symbols, namely greater than, less than or equal to, greater than or equal to, is equal to, and is not equal to. As I hope you can see, we can easily construct logical propositions involving a pair of variables or a variable and a scalar using any of these binary operations. Furthermore, the propositions we construct in this way will have a truth value, just as we have seen that the proposition x is less than 0 has a truth value. Remember, importantly, that this is what is executed if the proposition is true, and this is what is executed if the proposition is false. If you remember that, you should have no difficulty with exercises involving these propositions. Good luck with the exercises as always, and thank you for your attention.